Okay, we're on page 262, section 5.4, called Solving Radical Equations. And we're going to take a look at the core concept first. They give you 3 steps for solving radical equations. And if you forget what to do, or you forget where you are in the process, go back to this and it will describe these steps to you on how to get the problems done. Here's what it says. To solve a radical equation, follow these steps. First, isolate the radical. Whether there's a whole bunch of garbage underneath it or not, whatever it is, the square root, cube root, fifth root, I don't care what it is, the radical part of it may have stuff added to it or stuff multiplied by it or whatever. Get that thing all by itself as though it were its own variable. Get it all by itself first. So isolate the radical on one side of the equation if necessary. Sometimes it's already isolated. Sometimes you have to isolate it algebraically first. Get it by itself. Then raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. Let's see what I mean in just a minute. This will make more sense as soon as we do this a couple times. Step 3, solve the resulting equation using techniques that you learned in the previous chapters. Be sure you check your solution. It's going to be a big deal today, checking your solution. Because in all of algebra that I teach and have to do with every day, there are three things that can cause a solution to be a false solution. One of them is if it you plug it back into the original, if it causes you to divide by 0, you reject it. It's called an extraneous solution. If when you plug it back in, it causes you to even root a negative, you reject it as an extraneous solution. Or, and you haven't run into this yet, or if it causes you to log a non-positive number, you reject it as extraneous. You haven't run into that. So for you, there's only 2. Division by 0 or even rooting a negative number. Which one do you suppose it's going to be today you got to look out for? Even rooting, yeah, because that's what we're studying is radicals. So you're going to have to check every answer to make sure that it actually works and causes you to square root a positive. All right. There's also one other thing that can cause a hiccup for extraneous. You might want to pay attention here. So the very first one is 2 square roots of x plus 1 equals 4. Okay, first step in the process, it says, first thing you should do is isolate the radical. The radical part is the square root of x plus 1. What's tied to it? It's being multiplied by 2. We got to get rid of this by division. So you treat this like a variable, the whole thing like a variable. It's 2 times it, get rid of the 2 first. By division. Once the radical's all by itself, the way you undo a square root is to square. So you square both sides. That's how we're going to get rid of the radical part, is by doing its inverse, which is squaring. So on this side, I now have x plus 1 because the squaring undid the square root. And over here I have 4. And then solve from that. It's pretty easy. But you need to check it in the original. This is 3 plus 1 is 4. And the square root of 4 is 2. And 2 times 2 is 4. So we'll keep it. It's a good one. Good solution. Didn't cause any problems.
So it doesn't equal 4, it equals 3?
X equals 3.
Oh, okay.
Then, next one, B part, is the cube root of 2x minus 9 minus 1 equals 2. Nine, did I say? 2x minus 9?
Yeah, minus 9 minus 1.
Equals 2?
Yep.
Okay. So again, we're going to look to see if we can get the radical all by itself if necessary. And it is necessary. That one's tying things up on this side. I want to get this all alone on the left, so I've got to add 1 to the other side. Once it's been isolated, the next thing is to get rid of the radical.
So
This time we will cube it, yeah, exactly. Because the inverse of cube rooting is cubing. Cubing a cube root undoes it, so I must cube both sides because that's algebra. Keep things balanced. So on this side, cubing undid that cube root, and I just end up with 2x minus 9. But on this side, I have 27. Okay, so far? Now it's easy. 2x equals 27 plus 9 is 36. Divide 36 by 2 and you get 18. But does it work? Well, it should, because you can cube root anything, right? It should work. Let's just check it out. 2 times 18 is 54. 54 minus 9 is what?
45.
45?
2 times 18 is 36.
Oh yeah, 2 times 18 is 36. I was thinking 3 times 18, sorry. I was looking at that. My mistake. You're right. 36 minus 9 is
27.
27, and the cube root of 27 is?
3.
And 3 minus 1 is? We'll keep it. Works out when you do the arithmetic right. Which I didn't. Example 2 talks about an equation in meteorology, weather telling. Here's what it says. In a hurricane, the mean means the average. The average sustained wind velocity V can be modeled by, it's a function of pressure. Did you know that low pressure causes hurricanes? Low air pressure, it starts to circulate. Okay, so the speed of the wind is a function of the pressure in the area. And it is related this way, 6.3 times the square root of 1013 minus P, where P is the air pressure in millibars at the center of the hurricane. So here's what we're to do. Estimate the air pressure. We're supposed to find P. Okay? Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5. So where do we put the 54.5?
Minus P is
Let me write the equation up here. V of P, velocity as a function of pressure, is the square root of
1013.
6.3 first. Hang on a minute. 6.3 times the square root of 1013 minus P. By the way, 1013 is standard pressure at sea level. That's what they base it on in millibars. Okay, so that's our formula. Which of the variables, what did they tell us? What's the one thing they gave us?
The pressure, right?
54.5 meters per second. Does that feel like a pressure value or a velocity value? Velocity. So where should it go?
In the V.
Right here. What was it? 54.5 meters per second. Now, you haven't got a good feel for meters per second. If the wind was 54.5 miles per hour, that'd be something we around here can relate to, but we get this every spring at some point, right? This is not that big of a deal. I mean, it blows things all over and it's really inconvenient. It's a bummer to go outside, but this is not miles per hour. This is meters per second. This is particles moving through the air, half a football field in a second. That's pretty fast. Equals 6.3 times 1013 minus P. So now we're going to try to find the pressure. We're in the very same boat we were over here if we put this in the right place. First thing we do is isolate the radical by dividing by 6.3. So what's 54.5 divided by 6.3? I don't know what that is. I haven't got my calculator. Tell me.
8.65.
8.65 equals the square root of, keep your calculator handy. Now we get rid of the radicals so that we can get at P here. We can't get it. He's kind of trapped behind there. We got to square that off and square that. What's 8.65 squared?
74.83.
Point what?
83.
8.2. Give me all four decimals.
2 after
0.8225.
8.8225.
Okay. Equals 1013 minus P. So now I got to take 74 point this thing right here and subtract 1013. What do we get? Negative
838.16.
838.16?
No, negative 938.
938. Point what?
16.
Keep going.
37.
That 37 what?
692.
Equals negative P. So that means that P equals that because you can divide both sides by negative. That's in millibars. And then you round to whatever value they tell you to. It doesn't tell us what to round to. They round it to just the nearest 10. So it's 938.2 approximately.
Wow. 5.2. Oh, yes.
Approximately equal to the pressure, and that's in millibars. We call them MBs. Millibars of pressure.
What are millibars?
It has to do with when they first put together a barometer. A barometer measures air pressure, and it was just an small open dish of mercury, and there was a capillary tube stuck in it like a straw. And so you would push the air pressure, the heavier the air got, the more pressure it got, it would push down on that surface of mercury and push it up. The capillary tube, much like a thermometer. And so this is called millibars of mercury. They don't ever do it like that anymore, but that's still the standard pressure measurement in metric anyway.
So wait, are those like the thermometers that like, I don't know, my grandma had one in her living room where it's like a glass cylinder and there's like little like bubbles and they come up and each one has like different measurements on it.
I know.
Okay.
You're talking about temperature?
Yeah.
I've got one of those right up there, it's a little baby one. I think, where'd it go? I have it somewhere, it's over here. Oh yeah, it's right here. I got so much crap over there, I can't even see what I got. This does have to do with the expansion and contraction of
Yeah.
fluids and whether it will cause something to be buoyant or not. That's not what we're talking about. This is a temperature measurement thing, and it's really cool.
Yeah.
It was first devised by Newton, but perfected. I mean, these things are pretty accurate. I got a great big one at home. And when I build a fire, you can just see them start to drop. In my basement, it's always cold down there. I build a fire, and after about 30 minutes, they all start coming down. Oh, let's get warmer. But no, that's not what that is. It does have to do with pressure in the water, in the fluid that they float those in. But no, that's not what this is. It's mercury. It's pressure pushes that when the air gets heavier, when there gets to be more molecules based on weather systems that move in, it pushes down on that. The old style dish of mercury, so it pushes down hard on it, which pushes the mercury up the straw that's in it.
Oh, okay.
And as it goes up, it tells you there's more and more pressure. And as it comes down, it's because the pressure is lifting, and the mercury is able to fall back down into the dish.
Yeah.
So they're all related. Okay, ready for example 3? Here's where things are going to get ticklish here. Here's where things are going to get a little rough for you. Not too bad, but a little bit. Because now we're going to put x's on both sides, inside the radical and on the other side of the equation. We got to deal with that. It's not that bad. You'll be all right. All right, one we're going to deal with first, example 3, is x plus 1 equals the square root of 7x plus 15. Okay, first thing we're supposed to do according to the steps is isolate the radical. Done. There's no isolating to do. Next thing is to square or cube or fifth power or whatever, square off the radical. Get the radical by doing its inverse. This isn't understood 2 here, so I will square it off, but I have to square the entire other side. So that on this side, I have 7x plus 15 because I squared off the radical. On this side, I have x squared plus 2x plus 1. For those of you, do you understand that that's how you square a binomial? That you can go straight from here to here? Who doesn't get that? Anybody? It comes from this. X plus 1 times x plus 1, because that's what it means to square it. And whenever you square it, you always get twice this stuff in the middle. When you FOIL, the OI is outside, inside. You always get the same thing here as you do here. So it's always double this times this. Okay? We square the front, we square the back, and it's double this times this in the middle, because you always get 2 of them. Okay. So the resulting thing from squaring both sides to get rid of that radical is now a quadratic. And the way we handle quadratic things is to get everything on one side, hopefully on the side where the squared term is positive. So I'm bringing those guys over here. You with me? So the next move is we have to set quadratics equal to 0. So we can either factor, quadratic formula, polyroot find, something, but it has to be set equal to 0 if it's a quadratic or anything higher powered than that. So what I have is x squared plus minus actually 5x minus 14. Is that good? Okay? My first instinct is to try to factor it, because if it does factor and I can tell in a relatively short period of time, it's much, much quicker, and this thing factors. Because there are factors of 14 that subtract to be 5, and 7 and 2. It's going to be x and x. I have a 7 and a 2. If I want a -5 here, I'm going to need the 7 to be negative and the 2 to be positive. And if you're not a really good factorer, then jump to your poly root finder, but it will take you longer than it does me. X equals 7 and -2. 7 from this one, -2 from this one. Is there anyone not following to this point? Anybody? Now we got to check them out.
Oh.
Remember that this was not squared to begin with. So I'm going to write the original equation up here so that we can remember what it looked like before we tried squaring. So I'm going to plug the 7 in. Stay with me on the arithmetic. 7 plus 1 is 8. 7 times 7 is 49. Plus 15 is 64. Square root of that is 8. Okay, so that one's a good one. Let's try -2. Now, just because it's negative doesn't mean we reject it, though it's probably going to fail. Here we go. We get -2 plus 1, that's -1. And by the way, if you'll just remember this, you can't square root anything with this symbol on it and get a negative. This thing's going to fail. Plug a -2 in here, I'm going to get -14, right? Plus 15 is 1, whose principal square root is 1, and -1 does not equal 1. And it's very helpful to me on a test. If you show me both solutions and cross one out, because I know then that you checked it and kept whatever. It's nice to see them both. Just cross it out. Say that's extraneous, and that gives me an indication that you checked it like you're supposed to. -1 failed, or -2 failed, and it didn't fail because it was negative. It failed because when we plugged it in, we didn't get any quality. Okay, example 4 is one of the most miserable equations in all of math, and we're not going to do it. We're going to do one like it, which is, it's very, very much like it, but handled much, much more simply. Okay, so I'm going to give you another example that you will see on your exercises. They just don't have one for you in the book. So I'm going to replace example 4 with one of my own. And it looks like this instead. So don't look at example 4. Look at this instead. It's going to be the square root of x plus 2 equals the square root of 3 minus x. So now we've got a radical on both sides. Shouldn't be too hard to take care of. Since they're both square roots, we just square them both off. This gives you x plus 2 equals 3 minus x. And get after it. That's going to be 2x equals 1. X equals 1/2. Did you catch that or not? Did I go too fast? Anybody?
Why did you get 2x? Because it's x plus 2.
You've got to add x to this side.
Oh, okay.
And then subtract 2 from this side.
Okay, yes.
So we get 1/2 when you check it out. Oh, brother.
No, don't just do both of them.
What?
Do the 3 minus 1/2 and 2 plus 1/2.
Yeah. Yep. And you get 2.5 each time. So you're square rooting 2.5 both times.
Yeah.
So they're equal. Yep. Yeah, you don't have to square root 2.5 and get a crazy number. All you got to realize is that when you put a 1/2 in here, you get the square root of 2.5. And if you put 1.5 in here, you get the square root of 2.5. And the square root of 2.5 is equal to the square root of 2.5 without getting tied up with radicals and strange numbers. So that wasn't too bad, right? All they did in example 4, if you look at it, is add a 1 to one side, and that makes it, right there, makes it just horrible. I can show you how to do it if you want. There will probably be a bonus question like it on the test, but it's an awful process. Lots and lots of opportunity for mistakes. So I'm not going to do it unless you want me to at the end. Okay, moving on. Now we're going to solve radical equations where we don't actually have a radical symbol. All we have is fractional exponents. Aren't fraction exponents the same thing as radicals? I mean, you can convert from one to the other, right? So if you want to, you can convert. I'm going to deal with the radicals themselves. I'm sorry, the exponents themselves as being fractions. And there's two things that you need to be aware of and remember. You've been taught this before, but they come into play here, and you may not be able to recall them from your memory unless I should remind you. And that is this. whenever you take any number at all, I don't care what it is, and multiply by its reciprocal, you always get 1. It's called the multiplicative inverse property. Probably have forgotten it. You take 3/4 and multiply it by 4/3, you're going to get 1 because you get 12 over 12. Here you get 4 over 4. Right? Are you convinced? Any number times its reciprocal is 1? Okay, want to keep that in mind. That's going to become very handy in just a minute. Also recall this property of exponents. That x to the m raised to the n is equal to x to the mn. You multiply in that situation when you power a power. Okay? Remember these two facts. Multiply a number by its reciprocal, you get 1. And if you power a power, you multiply the little dudes. Okay, so let's tackle one here. Example 5 says 2x to the 3/4 plus 2 equals 10. 2x to the 3/4, did I say plus 2?
Yeah.
Plus 2 equals 10. And this, if you'll remember, if we convert from one to the other, that's the radical part right there. The only thing under a radical, if there would be a radical, is that x. It's 2 times some radical of x plus 2 equals 10. I got to get rid of this 2 by subtraction, and I got to get rid of this 2 by division before I'm ready to tackle the radical. That's that first step he was telling you about. Isolate the radical first. Well, this is the radical. So I'm going to have 2x to the 3/4 equals 8, and then x to the 3/4 equals 4. Follow that? Who'd they say?
Ariadne.
Okay, all right. Everybody follow this part right here. You got to get this done first. Then we want to have x be all by itself, and it's raised to the 3/4 right now, so I'm going to raise it to the 4/3 because 3/4 times 4/3 is 1. Right? And when I multiply, when I power a power, I multiply the powers, and that would be 12 over 12, which is 1. That just gives me x. But what you do to one side, you got to do to the other. Okay? And we get, I don't know what that is. I don't know what the cube root of 4 is. What? Did I do it wrong?
5.3. 5 1/3. Or 16 over 3.
6.3. Yeah,
Oh, I wrote the whole dang problem wrong. This would be correct if the problem were written correct. If the problem were written like this, this would be correct, and it would be some weird, strange, irrational number.
So you have
But it was this. That's different. So I got to start over. Sorry. This changes the problem. The way I had it written, the way we followed through would be perfect, except for 4 to the 4/3 is something irrational. They want us to get something nice first time around. That's why I was a little worried. And then I looked at it and said, oh, nice going, Johnson. Okay. So same, okay, start again. Get rid of the 2 because that part's the rational and the 2 is involved in that. So it's going to be 2x to the 3/4 equals 8. Yeah, we good? Then we're going to 4/3 the whole mess. 8 is cube rootable. That's nice. Okay, so it's going to be, when I multiply this part times this part, I'm going to get 1. So I end up with 2x over here. That's how I got rid of the radical, if you will, the radical. And I'm going to cube root 4. I'm sorry, cube root 8, which is 2. I'm going to 4th power that, which is 16. So x is 8. Now you can raise 8 to the 4/3 and it'll tell you it's 16. That's fine. Just make sure you put 4/3 in parentheses. You'll be okay. And then divide by 2. So this is how we got rid of the 3/4 by 4/3ing it. Okay, try another one. X plus 30 to the 1/2 equals x. X plus 30 to the 1/2 equals x. Okay, first thing we do is isolate the radical. It is. It wasn't over there. We had to get rid of the 2. Remember, before we could do it? This one over here, the radical's already isolated, and so we multiply by this power's reciprocal on both sides. The 2 times 1/2 takes care of that, so I end up with x plus 30 equals x squared. Now we've got a quadratic. I prefer to move both of those over there rather than the x squared over here, because if I'm gonna factor something, I want this term to be positive. So I'm gonna write 0 equals x squared minus x minus 30. And I can clearly see that's gonna factor. I don't know if you clearly can, but I can. Did you catch that? You get to that? So x is either 6 or -5. Still have to check them out because we started out with a radical, which was, and I'll write it again so that we don't see all that junk with it. X plus 30 to the 1/2 equals x. If I plug 6 in here, I'm going to get 6 plus 30, which is 36. Square rooted is 6 equals 6. I'll keep that one. This one's going to be -5 plus 30, which is 25. Square rooted is 5 equals -5. That's not the case. When you square root something, it's the principal square root. And I ended up with 5 equals -5, and that's not true. You okay or not? See what happened? I hope. Okay. One more example. It has to do with inequalities, and this is going to get messy. So if you've been kind of drifting off or falling asleep on me, wake up now, because this is going to get you. Inequalities are weird with radicals. Here's what we wish to find. Solve 3 square roots of x minus 1 less than or equal to 12. 3 square roots of x minus 1 less than or equal to 12. So what we will do is solve this like normal. And if any place in the process we have to divide or multiply by a negative number, we'll flip the sign over. That's still a rule. But we're going to, other than that, we're going to treat it like an equal sign. But there's something at the end you got to pay attention to. Okay, so first thing I'm going to do is isolate the radical by dividing by 3. That's not going to flip anybody's sign over because 3 is positive. The first thing is x minus 1 is going to be less than or equal to 4. Then I'm going to square that thing off. Squaring does not affect the sign either. X minus 1 less than or equal to 16. X is less than or equal to 17. Right? But there's a limit to the numbers less than 17 that will work. And that's the part you got to pay attention to. See, for example, -100 is less than 17, right? The -100, if I plug it in here, it's not going to work. -100 is not a solution because -100 minus 1 is -101, and I can't square root a negative.
So it has to be greater than 1.
Exactly. So you get a solution from doing this, and then if, especially if it's less than, if it's greater than, if x is greater than 17, anything greater than 17 is going to work in here, right? So you don't have to worry about it too much. But if it's x less than 17, not everything less than 17 will work in here. And so this, exactly what you just said, you would say, you have to consider, this thing is called the radicand. It's a weird word. That stuff inside that we're square rooting is called a radicand. And you have to not only consider the solution that the algebra gave you, you always have to consider the radicand also. So there's another equation. You have to force x minus 1 to be greater than or equal to 0 also. That has to be, or you can't square root, right? The radicand has to be 0 or more. So if we solve that one, it's a quick, easy solve. And we get just exactly what Rachel said. So x has to be less than 7. Also has to be greater than 1. Or we can't square root it. So the algebra gave us the 17. The radicand that must be greater than or equal to 0 gave us the 1. And so the solution is x must be more than or equal to 1. And at the same time, less than or equal to 17. Yes.
So instead, it was like a cube root. Would we be able to?
You'll be fine because you can cube root anything.
Yeah.
Positives and negatives. But if this is an even root, typically a square root, this is an even root, you have to consider the radicand and it must be positive or 0. Okay. Now, if you were to graph these things, if you were, remember I told you the other day and I said nobody makes a big deal about a deal. If you want to solve this thing with your calculator, you could put this in y1 and this in y2. Still, let's look at what that looks like because it still may be difficult for you to interpret. But if you can interpret it graphically, it will verify what you did algebraically, or maybe just do it graphically. Take 3 square root x minus 1. Close that, and then y2, we're going to put 12. And you're going to need a few more y's, because if y equals 12, it won't fit on a standard screen. So I'm going to go to a window that goes from, I'll go negative 10 to 10 on the x's, but I'm going to go negative 10 to 20 on the y so I can see that 12. Oh, wait, negative 10. Oh, come on. Negative 10 to 20 by 2's. Ooh, still can't see the cross point, so I'm going to have to let my x's go out a little bit farther too. I'll let the x's go out to 20 as well. If I let my x's go out to 20 and my y's go up to 20, then you can see where they actually cross. Can you get that? We get the blue square root. It kicks off at 1 because we've shifted it to the right one. And then we get the red line, which is the 12 on the other side. You say, okay, well, I could find the solution to that. So we go calculate and intersect. Enter, 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 and it jumps to the intersect. This is what I get if I graph. And we find that that intersect gave us the 17. So I'm going to draw a quick sketch of this so I can talk about it on video and also with you guys. This is what I get from my graph. It's going to start here at about 1 and go out like this, and the other one's going to come across like this. And this cross point right here is 17. Right? And so these values right here, these y values right here are less than 12 because they're underneath the line y equals 12. They're underneath that. But they only go to there. Nothing back here is less than 12. There's nothing less than 12 back here because there's no graph back here. So these are the values of x that work. That's how you interpret the graph in that. These are less than 12, but they stop being anything at 1. Which verifies this. This came from the algebra, considering the radicand and the algebra gave us this restriction on x. You have to think about it a little harder. Okay, when you're doing inequalities, make sure you consider the radicand. Okay, turn the page and voila, we are done. Okay, so isolate the radical, square, cube, or fifth power, whatever it is, off the radical, doing it to both sides, and continue solving with the skills you have. Supposed to be doing it on paper. Here's the assignment. You ready to write? 3 through 11 odd. 14. 15 to 23 odd. 27 to 31 odd. 37 to 43 odd. And 46. That's not a horrendous assignment. It's 20 problems. Bill will handle that. The first ones will go pretty quick for you.